Despite its reputation for being awkward and maybe a little arcane, trigonometry is actually one of the oldest and most useful subjects in mathematics. Trigonometry is the foundation of techniques for navigation and surveying and engineering, and has its roots in the scholarship of ancient Egypt and especially Babylonia, who did most of the work to develop trig, as well as a complex and remarkably effective base 60 number system and a sort of proto-zero concept that was centuries ahead of its time. We incorrectly give credit for a lot of this to the Greeks, but that's only because they realized it was all worth writing down. The name by itself suggests that trigonometry has a lot to do with triangles, and yes, we are able to use three-sided polygons in a number of important ways due to trig rules and functions. But to understand what's really going on with trigonometry, we need to back out of polygons entirely and start with angles. A quick recap. An angle is formed by two rays, or lines which start at a set point and continue on forever. In formal setup, the horizontal ray is the initial side, and the other one, wherever it is the terminal side. We measure an angle not by measuring a linear distance between the two rays, because that changes constantly, but by measuring the arc, or the segment of a circle, that the two rays create. A circle's angular measurement is 360 degrees. Thank both the number of days in a year and the Babylonians with their base 60 math for this tradition. If we superimpose a circle on top of an angle situated with the rays originating from the center, we can find out how much of the circle, or how many of those 360 degrees, are between the two rays. Quick note, there's nothing that says that we have to stop once we get to 360. It's just that going around more than once, or even backwards, means that we'll end up at the same spot. A 420 degree angle or a 780 degree angle is exactly the same as a 60 degree angle, which is the same as a negative 300 degree angle. These are all called coterminal angles. That 360 degree standard is very useful and very common, but for what we will be doing with trig, it's not necessarily the most convenient measurement. For that, let's go back to circles. Funny thing about circles, the circumference of a circle is in a locked relationship with its radius. The size of a circle does not matter in this respect. A circle's circumference is always its radius times 2 times the circular constant pi. Because of this 2 pi r relationship, we can actually use the radius of a circle to measure distance around the outside of the circle, and by extension an angle. When we use a radius to measure distance around the circumference, we call that distance a radian. There are 2 pi radians around a circle. Converting between the two systems is simple. If a full 360 degrees is 2 pi radians, half of either is 180 degrees or 1 pi radians. Half of that is 90 degrees or pi over 2 radians. 60 degrees is pi over 3, and so on. To convert from degrees to radians, divide the degree measure by 180 and multiply by pi. To go from radians to degrees, do the exact opposite. Divide by pi, multiply by 180. Coterminal angles work exactly the same way either way. Admittedly, this will feel a bit unnecessary right now, but as we get into the trig functions themselves, the use of radians will make much more sense.